Greetings from the GNU Linux users group. In our previous video, we have discussed about how website works, but what we are really interested in is in the security of those systems. In this video, we will actually be looking upon different type of web attacks, how unsecure web design leads to major flaws which can be exploited by malicious third parties, and look upon one major kind of web attack that is quite prevalent in this field, the distributed denial of service attack or a DDoS attack. In our last video on the working of websites, we saw different languages like JavaScript, PHP are used to write code for running the websites. But one thing I would like to add is that generally websites have a lot of features, and with that the amount of code written to implement them increases. Thus we use frameworks and libraries to ease our task. One chooses a framework depending upon the application he wants to build. Some common and widely used are Node.js, Django, .NET, etc. Now, there are a large variety of attacks present to exploit web systems. Among them, some common and well-exploited ones are brute force attacks, or XSS, or cross-site scripting. Now, XSS is one of the quite popular attacks used to exploit JavaScript websites. Cross-site scripting works by manipulating a vulnerable website so that it returns malicious JavaScript to users. When the malicious code executes inside a victim's browser, the attacker can fully compromise their interaction with the application. We also have CSRF or cross-site forgery. It is a web security vulnerability that allows an attacker to induce users to perform actions that they do not intend to perform. It allows an attacker to partly circumvent the same origin policy which is designed to prevent websites from interfering with each other. There are other attacks like SQL injection, remote command execution, and much more, and we will also be learning about a few of these attacks in the coming videos. Coming to XSS or cross-site scripting. Websites vulnerable to cross-site scripting takes unchecked input by users, which may be exploited by an attacker, where instead of a proper input, an attacker may pass a JavaScript code which will be executed locally on the browsers of the users using the website, which may lead to several consequences like password leaks, redirection to other malicious websites, or the entire system being taken in control by other attackers. Now, the name cross-site request basically explains the gist of this whole attack. Basically, what happens is that an website generally has several URLs or endpoints to which an authenticated user sends requests to perform certain restricted actions, which can only be performed by the user. For example, let's say a password change. Now, there will be a certain URL to which the user will send request to change his password. Now, this URL is public, but why can't anyone else change my password using this URL? It's because every user is authenticated on the website, and there may be authentication tokens that distinguish one user from another, and one generally can't perform another account's action for other. But the catch here is that we can hardcode a malicious website which can send the same request from the user's endpoint to the target website and keep this process hidden from the user to stop him from knowing what's happening behind his eyes. This way, an attacker can take control of a user's account on a vulnerable website without even the user knowing. There are also other type of attacks, like if you talk about file upload attacks, many websites let you upload files which can be for a variety of reasons. What if you upload a PHP file or other code instead of a PDF text file that will execute itself on the server and may generate a remote shell or terminal which give you the control of the entire targeted server? Then there is SSTI, or server-side template injection. This type attacks websites using vulnerable templates which takes unchecked input from the user, where a user can pass code through the input that will execute in the server backend and will let a third party gain control of the system. There are many more attacks that I can't even list here, and if you want to learn more about all of them in more details, check out this website which has extensive articles along with labs in which you can test out your skills. We know from our previous discussion that the web generally stands on an application layer regulated by certain protocols such as TCP, UDP, NTP, etc. These protocols were some of the oldest protocols created and have inherent security flaws that may be exploited by attackers if not regulated and checked by servers. For example, let's talk about TCP, the most basic protocol used for HTTP connections. We have seen TCP send requests in plain text to a server and also receive similar kind of response. This level of transparency to the users may introduce a risk of tampering the original data to a malicious one that may exploit bugs present in the server if there is any, which may lead to escalated privileges and compromise of the entire system. As you can see here, we have a basic structure of a web system where a server runs multiple instances of a program. It receives user and client requests and pipe them into the programs they are meant for. Now for a compromised system, let's assume this instance has a security bug, as you can see here, which can be exploited by a certain input that triggers this bug. The system is orchestrated in such a way that the client sends only certain data to the program that doesn't reaches this condition. But inherent flaw of web requests to send data in plain text format may lead to a malicious party tampering these packets from their end and inject a certain code, also known as a payload, which will trigger this condition and give root privileges of the server to this malicious user, and compromise all the data present in the system even if it originally did not belong to the program. Now to protect our server from this type of attacks, we either have to fix the flaws existing in these web protocols or modify our code in such a way so that the least amount of bugs are present, and if present, they must not be so severe so as to compromise the entire security of the program. Now since web protocols are widely used in a variety of places, changing all of them at once will be a tremendous task. Thus we will only focus on the latter solution. Thus proper security design and bugless code plays a tremendous role in the security of IT systems. Coming to the main topic of our discussion, DDoS attacks or distributed denial of service attacks. Nowadays, DDoS is quite extensively being used to hinder common web services. Now in DDoS attacks, the general attack vector is to send a large amount of web requests to a server so that it cannot distinguish between authentic and fake requests, and unable to process so many requests at once, it gets crashed. To make things simple, think of DDoS like this. We have our server allocated to a certain IP address and having a certain bandwidth allocated to it, let's say 200 Mbps or so, and also a limited processing power not to mention. Now think of our friend having a more powerful computer with a better internet connection, let's say 10 Gbps. So if our powerful computer uses all of its processing power to generate requests and send all those requests through that high bandwidth allocated to it, what will basically happen is that all those requests will throttle all the processing power and internet available to our computer, and will make it impossible for other processes running on this machine to use the resources available to it. Thus, if we are running some kind of website or a server in our machine, it would be inaccessible, making it look like our website has crashed. In general scenario, this computer is the actual server running the targeted service. Now practically, in real world, servers have quite large processing powers, and no single computer is capable of producing such bulk that can exhaust that level of processing power. So what's the catch? But there's a way around. Instead of having one single computer generate all those requests, we can have say 1,000 or 2,000 computers or even more generate a few hundred requests, that even though it will be minimal for computers generating the request, but for the target it will be millions of web packets flooding it, leaving it unreachable by authentic users like you and I. Now generally, these computers are connected in a network known as botnet, controlled by a malicious third party, and they generally become a part of a botnet most of the times when infected by malwares. Recently, proper security patches, antiviruses have been able to reduce the number of botnets to a large extent, but with time other types of DDoS attacks have been devised, which does the job more efficiently and sometimes bypass the filters placed in order to prevent DDoS. Some well-known DDoS techniques are DDoS amplification, slow loading attacks, etc. We will not be digging deep into these attacks for now, but you can Google yourself and find out more about these attacks and how these attacks works. With this, we come to the end of today's video. In the next video, we'll look in depth and walk through a practical approach to one of the most common web attacks, the SQL injection. Till then, stay tuned.
Back from the dead.